Hi guys, this is Dr. Huan. We are going to talk about section 9.5, the combinations. Okay, we are going to learn how to count subsets of a set. Now, in this section, let's first introduce the combination. Say let n and r be non-negative integers so that r is less than or equal to n. Basically, n is the size of the set and r is the size of a subset of this set. So therefore, the size of this has to be less than or equal to the size of the original set. We call an r combination of a set of n elements is a subset of r of the n elements. Okay, so basically r combination is a subset of a set. Now this symbol, we read n choose r, denotes the number of r combinations. Other notations can be like C of nr or ncr, n choose r. Let's first try to make sense of what r combination is by looking at this example. So suppose the set S contains 4 people, Anne, Bob, Sid, Dan. And let's list 3 combinations of this set S. So that means the subset of size 3. That's what 3 combinations mean. So obviously you just try to list all the possible size 3 subsets from this set. So it can be Anne, Bob, and Sid, right? And can be Anne, Bob, and Dylan, and Dan, I'm sorry. And then Anne, Sid, Dan, Anne, Sid, actually, well, I have and that we have listed that already. I think Bob, Sid, Dan, that's all. I think that's all the possible subsets of size 3 of this set. Now, what is 4 choose 3? Now, what is 4 choose 3? 4 choose 3, n choose r means the number of r combination. In this case, the number of 3 combinations. That's 4. That's 4. We already listed that. That's 4. So now we really are not like explaining how actually this can be computed. We just focus on the concepts, the understanding of the concept of R combination and the meaning of this n choose R. And then we'll introduce how to actually compute this guy right there. We even though we learned this formula back in chapter 5, we're going to derive this formula now from another perspective. The difference between R permutation and R combination. When an order selection R elements from n elements is an R permutation. So when you have an order selection, that's a permutation. And then unordered selection of R elements from n elements, that's called combination. Okay, so basically permutation order matters. Combination, the order doesn't matter. So for instance, if we look at previous example, so this guy, BAC, when you have that, from permutation perspective, this will be a different order from this one. They will consider as 2 different permutation when order matters. But from the combination perspective, if you just look at the combination, then they have the same elements. So these 2 will be considered as the same combination. Now, how do we derive the result? The result for this one. Let's take a look at this way. 2-step process to form an R permutation of an n element. Okay, so how can we form a R permutation from n elements? Step 1, we can choose R of n elements from the set. So number of ways to do that. We just introduced this concept. The number of ways is n choose R, right? That's that means how many ways to form R combination. So n choose R. Now once we choose n R elements from the set of n elements, then how many ways to order these R elements? It will be R factorial, okay, and therefore P, the permutation, the R permutation of n elements, this can be formed by these two steps. Step number one, choose R elements from n elements, which is n choose R, times how many ways to order the R elements chosen? R factorial, so R factorial. Now, therefore, how do you compute this guy? Simply divide both sides by R factorial, right? So therefore, this is going to be P, the R permutation of n, divided by R factorial, okay? So this is how we compute, how we derive this result. And if you recall earlier, back in in an earlier section, how do we compute the permutation? The permutation P, the R permutation of n is equal to n factorial divided by n minus R factorial. That's how we compute that. So therefore, when you plug this in here, you get n factorial divided by n minus R factorial. That's the permutation, and divided by R factorial, right? So therefore, if you simplify it, you get this n factorial, n minus R factorial, and R factorial right there on the bottom. So you either use that or use that, okay, to compute the n choose R. Now let's quick review how we actually use the formula to compute that, okay. So this is equal to, n is 11, so 11 factorial, and n minus R is 3, so n minus 3, which is 8 factorial, divided and then also R factorial, which is 3 factorial on the bottom, okay. So, and this is equal to, and oftentimes I do not compute 11 factorial, I try to cancel, so which means 11 times 10 times 9 times 8 factorial, right? Divided by 8 factorial times 3 factorial, okay? 3 factorial. And then 8 factorial can be gone. And 3 factorial is equal to 6. Okay? So, and then after the algebra, you can do the 990 divided by 6, which is 165, right? And then the next one is you need to be familiar with all these kind of notation. So this also means a combination, A choose 1 basically. So this is the same as A choose 1. And so basically just imagine how many ways that you can choose one element from 8 elements. How many possible subsets that you can find of subsets of size 1 from a set of 8 elements? There will be just 8 ways. Now, so using that thinking, you can conclude that it's going to be 8, but let's verify this using this formula, using this formula here. So it's going to be 8 factorial, 8 minus 1, which is 7 factorial on the bottom, and then 1 factorial. And the 8 factorial over 7 factorial, you can rewrite 8 factorial as 8 times 7 factorial, and 7 factorial will be cancelled. So 8 times 7 factorial times 1, and then this can cancel. So you can see that this is equal to 8. And let's take a look at 8 choose 7. So similarly, 8 factorial divided by 8 minus 7, which is 1 factorial, times 7 factorial, right? And if you look at that, that's identical to that. It's just a little different order here. So it is the same as 8. I hope through this experience you can see 8 choose 1 is the same as 8 choose 7. This makes sense because just think about when you choose one person out of 8 person, there's 8 ways to do that, right? 8 different ways, number of different ways will be 8. And when you say 8 choose 7, you can think about, so 8 choose 1, that means, let's put it this way. If you want to find a person to do a presentation out of the 8 person, so you have 8 ways to choose one people, right? And then so 8 choose 7, that you can think about this as like you choose 7 people from the group of 8 people, and these 7 people are not the ones to do the presentation. The remaining one will be doing the presentation. So therefore they are actually the same thing. Okay. Well, in general, n choose 0. What is n choose 0? Just choose. Think about, you choose no one from a group of n people. How many ways to do that? Just one way. You just do not choose anyone. Or mathematically speaking, you can think of this as n factorial. And then n minus 0 factorial, which means n factorial, right? And then 0 factorial. And these two can cancel. And then 0 factorial by definition is just 1. So therefore this is going to be 1. And n choose 1, it will be n. Just how many ways to choose one person from n person? There are n ways. N choose n, how many ways to choose n person from a group of n person? Only one way, just choose them all. And mathematically speaking, this is n factorial divided by 0 factorial and n factorial, and then you can see they all cancel, and the 0 factorial is 1. And by the way, you will not be surprised that these two are actually the same. So in general, in this video, I'm going to close by this. So n choose r will be equal to n choose n minus r. In general, this is going to be true. This can be proved easily. So in the future, if you say 10 choose 8, instead of finding 10 choose 8, you can find 10 choose 2, a smaller number. Okay, so that concludes the first video, which is introducing the formula for this combination, and then introduce the concept of R combination. And in the next video, we are going to do a whole bunch of exercises that's very much needed for you to be able to count correctly.